Well, I'm not sure here there exists a traffic engineering algorithm. Driving in from the airport at almost midnight through dense traffic, it was like, that's just crazy.
So I think you can run 4 or 5 in Santa Monica at midnight.
Never been through Santa Monica at that hour. They've removed part of the key instructions here. There you are.
Good job.
Trying to get that to present full screen and fail. Forgot the magic trick. There's some button you got to push and you don't know which one it is. That's it. We got it. No, it's still not full screen. I think there's a button up here we got to push. I don't know what the time it is. Yeah. Okay. Could you circulate these? Thank you. I haven't pulled up all the others. Really insurance coverage, but because we got it. It's not like we have a shortage of time. No. It's only the automotive one getting canceled. Okay. Thank you, folks. I'm Joel Halpern. This is Luigi Yanon. We're the co-chairs for the Lisp Working Group. Welcome to Lisp. We now are going to go through the chair's slides, starting with the note well. Turn this over to Luigi.
Thank you, Joy. So here are the usual pointers for the charter, the jabber, the streaming, the Mitico, and data tracker, where we have all the documents and slides. Yeah. So a little bit of an update on the documents. There has been a lot going on, and we will have a small update on this. So we have 68. Like I really have to stay close. Okay. So I was saying there has been in the last month or so a lot going on. We will have an update. So here is the status. We have 6834 bis that passed working group last call, but I mean, we have the main specs that we are working on, so we keep it on hold a little bit. Lisp GPE, same thing. We push forward. Shepherd's write-up has been done, and we have comments from the ISG will be solved. The usual intro document that has been there like forever. Okay, the BIS documents, we had a thorough security review, which actually the authors did very well, and they just updated the documents. There have been several updates, but yesterday. They submitted the latest version, and we will have an update. We have as well the registry for the messages that has been go through a short adoption call and working group last call, which is 8113 bis document, as well as gone through. We will deal first with the main spec and then we move this along. The security document, you know the history of this. It came back. We updated to be standard. Make sure to be compliant with the final spec, the main specs. Will most probably be mandatory to implement. We'll discuss this later, but we will move it forward as long with the main spec. Okay, and we have vendor-specific LCAF. Also passed the working group last call. Okay, I'm the shepherd. I'm waiting to write to prepare the write-up to see what happens with the main specs. Okay. So we will agenda today. We will have a short update on the young model, then a good update on everything that happened on the main specs. Okay. Then an update on the EID anonymity document, the ACDSA authentication and authorization document, and the PUB subscribe document. These are the working group documents. On the non-working group items, we will have a presentation by Victor on multi-domain Lisp. Also supposed to be here Sharon to talk about automotive networks, but he couldn't make it, so we have the time back. And we still have some time left to discuss anything we want to discuss on next steps at the end of the meeting. Okay? Any comment on the agenda? Okay, so let's start. Okay.
Yeah. Just a kind of comment on the agenda. We were referring to draft 09380.
Okay.
Yeah.
Minor, yeah.
Okay, good morning. My name is Prashad Raman. Just a quick update on the Lisp Yang model. So the current, well, the latest which was submitted is Rev 9. I'm going to be submitting Rev 10 later today. We're going to go over those changes very soon. Next. Oh.
You have the should work. No?
Am I supposed to click in a direction?
I'll use my finger.
Okay, thank you. So the changes we did in 09 are basically changes which we discussed last IETF in Montreal. In the virtual network list, we've mapped them, we've changed the so that the mapping of the VNIs to virtual network instances limited to XDRs can be XDRs, right, Dino? And we've added the security section, the security consideration section, which, according to the requirements of 6087 bis. So that section in 6087 bis basically requests that you identify nodes which could be sensitive from a security point of view. Next, please. And okay, so the changes which are going to go in 10 today are basically changes which I did and I forgot to include in the XML version of the document. Those also are changes which we discussed in Montreal. So previously, the VNI, also known by some as IID, was just a number, and we've changed it to be leafref to the virtual network table. So that way you cannot just put a number which does not map to any VRF. Also, we've made the network instance name mandatory, so that's your VRF name. Before you could just add a VNI which had no network instance name. And finally, we've made the network instance name unique so that you cannot map multiple VNIs to the same VRF. The document is ready. I'll be uploading that later today. Next, please. Okay, next step. Alberto actually this weekend pointed out that the Yang is a bit out of sync with some of the changes in the BIS documents. For example, there was an algo ID which was added, I think, in the BIS docs, which are not in the Yang. So we do have to add that to the Yang. And after that, you know, in about 2 weeks, we would like to ask the chairs to start a working group last call.
Hey, Rashad, on your VNI references,
Yep.
I think from the conversation we were just having, they may need to be updated to instances to be in alignment with all the specs.
Yep, I mean, I'm okay with that. Please send an email to the list. You already know.
Okay, thanks.
Yep, I agree.
So you kept talking about VNIs and you use VNIs in the mapping indices. What's supposed to happen if the VNI is the public internet? If there isn't a private, if it's not a private network, I'm looking at the mappings grouping and it looks like that's a mandatory key and I don't know what value you'd put in.
I mean, that's your default VRF, so you would have a default IID or default.
Well, but
default
you
VNI.
don't have an instance ID for the public internet. I'm a little confused.
So this is Dino. So if you encode an extended EID with an instance ID and it's for the public internet, the value is 0. If you don't include the instance ID, it's assumed to be 0 because it's unspecified and it means the capital I internet.
So we probably should note in the Yang that 0 is the value for public
Yeah.
internet.
And we'll double check the VPN document that formally defines instant ID, that 0 means public internet.
Okay.
Good point. So do you chairs or anybody in the room have any issue if after we've made those, I mean, those corrections which have been mentioned and with the algo ID here that we start a work group plus call relatively soon? I mean, I'm not stuck on 2 weeks or 3 weeks or 4 weeks, but I mean, that will push some people to read the document too, because I don't think it's got as much love as it should have, being Yang.
Being Yang, yeah. No, I think once you've made those changes, doing a 2-week last call and making sure folks actually read it and comment on it seems entirely sensible.
Yeah, there may be also something that we need to look at. This is Fabio Maino, Cisco. Related with the scope of the password, the shared key that is associated with the map registration, because we introduced the XDR-ID, and so we have changed that scope in 6833 bis. And so that might reflect on that.
Yeah, so in the private version, Alberto started making those changes, but yes, you're right. Those changes have to go in. Maybe they won't go in /10, but they'll go in /11.
Okay, so
Pretty soon.
just a note, yeah. Exactly. And
by pretty soon, I mean
might be in
sooner
already.
to
I'm
this
not-
IETF than the next IETF.
I'm not sure which version went through, but they might be in already.
Good. Thank you.
Good, thank you.
I should have everything uploaded.
Yep. Just upload the latest version.
You may want to click refresh.
Yeah, just do it.
Thank you.
Okay, so I'm going to present all the changes on 6830Bs and 6833Bs that we did after all the reviews. And instead of going through all the changes and detailing every single one, I will start by discussing a little bit the overall changes first, like a short summary of the important changes. Then I will list all the smaller changes. So the first one is that we have added a new section on both documents that it is actually stating where Lisp is applicable, so the scope of applicability. And here I'm quoting a paragraph on this new section, which states that Lisp initially was focused on the scalability of the internet, but during the design and development of Lisp, the focus changed on other use cases. And now the common property for such use cases is that Lisp is focused on a large set of cooperating entities which are seeking to communicate over the public internet or an underlay IP infrastructure, while keeping, and this is the important part, addressing topology separate from the internet topology, routing, and addressing. So this is one of the changes that we did on the documents. So because of this, we remove the term global from both specs. For instance, EIDs are not defined as global identifiers, but within this set of cooperating entities, and so on and so forth. So the second change is that now LispSec is mandatory to implement, and this is based on the following assumptions. So the control plane holds based on that the mapping system is secure and trusted, that ETRs have a pre-configured trust relationship with the mapping system, and that LispSec must be implemented. So this is stated in the control plane document. So as a result of this, and this is something that it is not posted yet, and this is just my interpretation of what we should do, so people can chime in and say if they agreed or not. But I understand that deployments that are concerned about this kind of security issues should, must drop control plane messages that do not contain LispSec material, which is the SBIT, EAD, one-time key, and packet authentication data. This is basically to prevent downgrade attacks. So any comment on that? No?
Just a comment, as we discussed this yesterday. Yeah, this is basically reflecting the fact that LispSec is mandatory to implement, and when deployed, it has to be deployed for that deployment, right? So basically to avoid the downgrade attack that are basically stripping the security part from the security feature of LispSec. Basically, all the parties will have to enforce that LispSec is actually used.
No, it's not Lisp. We're not calling for LispSec to be mandatory to use.
Yeah.
We're only calling it to be mandatory to implement. So if deployers wish to use it, they can count on it being available.
That's expressed much better what I was saying.
And
Okay.
this is what I tried to capture in this sentence. Maybe I was not very good at it, but this is what. So this is not the sentence that I.
That's a fairly standard.
Okay.
Yeah.
So we need to
If
add
you
this.
want it, require it.
So we need to add this sentence into the document. This is not yet in the latest version. Okay, then another change is an anti-replay mechanism, an anti-replay attack mechanism for map register. So this is to prevent this attack, which is an XDR is sending a map register to a map server. Then an attacker is intercepting this map, is capturing this map register and just replaying it, which means that it will register the same EID and the same error. So let's say that the XDR disappears, then an attacker can actually register for the same EID and error. So the idea that we have now, and notice the arrow timeline, so time goes from the left to the right. The idea that we have now is that the map server and ETR, they keep state, which is the last nonce used. And for each map register, the XDR needs to increment the nonce by one value, which means that if an attacker intercepts, captures one of these map registers, it won't be able to replay it because the map server only accepts map registers with the nonce which is greater than the last seen nonce. This is a very standard anti-replay mechanism. The state is kept on both at the XTR and the map server, and the nonce is indexed by the XTR ID. Yeah, this is here. So the nonce is auto-incremented in each map register. The nonce is returned in map notify message, which this is standard. This is as in the old version of the documents. Both ETRs and map server, they must store in persistent storage the last nonce, which is indexed by the XTR ID. If the state is lost, both entities need to rekey. They need to have new shared keys. And well, if the map register received with a nonce which is smaller or equal to the one stored, then the map server will drop and lock the message. Okay, then there is also a bunch of changes regarding UDP and congestion control for both documents, which is pretty much stating that implementers need to follow the guidelines from RFC 8085, which is UDP usage guidelines. And let's say a short summary is that for data plane, we need to follow, it is recommended to follow the congestion control mechanism defined in this document for data packets, plus the UDP checksum for deployments that are concerned about the integrity of the UDP or Lisp headers. Then for the control plane, this affects the transmission of map requests, congestion control and reliability of unsolicited map notifies, rate limiting SMRs, and the maximum size of Lisp control plane message, which all of these mechanisms, they are related to the 8085. So now I'm going to list all the changes, but I already explained the most important ones. So this is for data plane documents. So since last IETF, and this is pretty much because of the changes due to the reviews coming in, we went from /14 to /25, and this is the current status as for yesterday of the documents, of the data plane document. So overall and introductions, we removed the term global. We added the scope of applicability. I discussed already this in slide number 2, and that the reactions to LSB bits are rate limited by ETRs according to the same RFC 8085. So UDP, as I was saying, congestion control when sending Lisp packets, and optional UDP checksum for deployments that are concerned about UDP or Lisp integrity of the header. Then regarding the encapsulation, there are a few changes. The first one is small, is that the TTL or hop count must be, before we were stating that it should be copied from the outer header to the inner header. This is when decapsulating. And also it is recommended that implementers follow 6040, which is RFC describing how explicit congestion notification bits must be treated when tunneling. So that we recommend to follow these guidelines. Then regarding security considerations, we added, this is a minor edit, I think, but we added that off-path attackers are able to spoof the airlock, and the nonce can take advantage of the reachability mechanism, namely LSB, nonce present, and echo nonce to declare false airlock reachability information. And we added a specific example that was highlighted by the reviewers, where an off-path attacker can send forged echo nonce packets with random nonce, trying to guess the nonce to declare an airlock up or down depending on the goal. And we also did describe some mitigation techniques for this. And well, there are other changes on the data plane document that, for instance, that in load sharing, the source port should be the same for all the packets of the same flow, which is quite reasonable, and then other minor edits. So then going to the control plane document, we went since last IETF from /10 to /21, and this is the status as for yesterday. And overall, we again removed the term global, an example of a sentence, because this is throughout all the documents. Mappings are propagated across the mapping system, not globally, because of the new scope of applicability. We added the new scope of applicability, which is exactly the same as the one in the data plane. We state that we recommend to follow the guidelines on 8085 regarding UDP usage UDP for the maximum size of the Lisp control plane. this is where we describe the anti-replay attacks. This is exactly the same as I was explaining before. And we also include a sentence stating that the nonce must, before we were saying should, be generated by proper random sources. So because the nonce is indexed by the XTR ID, and the XTR ID was defined in another document, we now specify both XTR ID and site ID in the Lisp control plane RFC. So it's pretty much stating that if the I bit is set, then at the end of the map register, you will find XTR ID and site ID that uniquely identify the XTR and the site ID where the XTR is attached to. Then on security considerations, this is where we state that what I was explaining at the beginning, that LispSec is mandatory to implement, and the assumptions that we hold regarding the mapping system, which is secure and trusted, and that there is a pre-configured trust relationship between the ETR and the mapping system. We also describe DOS and amplification attacks that can be done by exploiting the map request and map reply message exchange. And we explain also how LispSec provides a set of protections: origin authentication, integrity, anti-replay protection, prevention of man in the middle, and prefix overclaiming for map request, map reply, message exchange, and that ETRs can overclaim the EID prefix it owns. So this is the kind of a summary of the attacks that, let's say, that it related to the control. And then there is a bunch of other changes. Oh, I forgot one, because there is a new version of the slides, but I sent them 5 minutes ago. So we also included a... Okay, so, no, that's fine. It's just one slide. So one of the comments from the reviewers was that we were ignoring privacy comments regarding the control plane, and we added a new privacy consideration section where we describe that a summary of the section is that EIDs are long-lived identifiers that somehow identify the node, and that they correlate with the airlog, which is the topological location of the node, and that this information is pretty much public within the Lisp deployment. And this introduces some privacy concerns that this can be mitigated by either using authentication mechanism for the mapping information within the Lisp site, or using ephemeral EIDs, for which we have already. No, access control list. That's one, right? And no, I think that in the section we said, so first you can ACL who can ask for mapping information. Then you can use authentication, which is a more advanced form of ACL, let's say, to identify who can have access to the information, or use ephemeral EIDs. Okay. So, and then this is the last slide. So there are a bunch of comments. So we simplified the abstract. There is a small change on the, not change. We are stating that there is a type 7 control plane message which is not assigned. We added capture to some figures. Then this is a little bit more important. Bits M and I in map request are now reserved and defined in other documents. And bit M is also reserved in the map register. So those are bits that were defined in the control plane, and now the control plane is just reserving it, and they are being used in other documents. There are many instances of may in capital letters that are now may without capital letters. These editorial changes. We are also using IPv6 addresses for the examples on some of the paragraphs. This is, I think it's recommended also by IETF. And some of the fields in map register, map notify, and map notify acknowledgement are defined in all this message, and they have the same meaning. So we are specifying that they are dual use. And then there are also a bunch of minor edits. And I think, yeah, this is the last one.
I have two comments actually.
Please.
So on the bits that you say here, that you say now reserved, actually they should be unassigned according to the comments of MED.
I think that they are reserved, right? This is what is written on the text.
We should look at it because according to to map. If we say reserved, they will not be used in the future. If they are unassigned, they can be used in the future, allocated.
So wherever there's references to bits that are labeled R, the explanation for them say reserved and unassigned.
Okay. It's not really compliant, but let's see. And the second was just a clarification. If you go back. Here.
Mhm.
So I think we should specify that the last in nonce is by ETR, because if we have two warlocks which are different ETRs, they both register to the same server. They can use different nonce, right?
So the nonce is indexed by XTR ID.
Exactly. So
Yes.
that's important message to let the last C nonce is by ETR, because we generally speak about last C.
But how, when you say ETR, you mean XTR ID?
Yeah.
Okay, this is what's written.
It's the same.
Okay, okay, okay.
Because
Since
That's it.
the ETR can move and change our logs, you want something that's persistent. So this is why we had the XTR ID in the spec to begin with, but since it was being used for NAT traversal, we took it out and we put it in the pub/spub because it had use. But now to do the replay attack, we put the XTR ID back in.
Eric, not my question. So I haven't read the spec on this, but these nonces, can they actually get out of sync? Suppose that the XTR is sending nonce 2. That map register is never received by the map server. It then moves and it starts sending nonce 3. That's never received by the map server, etc. Right? So the XTR, can it keep on advancing the nonces because it keeps on moving, and 3 days later when the map server shows up, it's advanced far beyond, and the map server still believes that nonce 2 is the next one that it should see. And if so, how do you resynchronize? So first of all, can it actually move that way, or does it only advance when it gets a map notified back?
So the XTR will know that the map server is not responding because it is not receiving the map notify. The nonce must be stored in persistent storage to keep track of the state.
But you didn't answer his question.
Okay.
The map server always accepts a nonce that's greater than or equal to the last one you received. Greater than, not equal. So it doesn't have to be +1, it's sequential.
Also, yeah, it might be detailed, but does it actually advance the nonce it's going to use only when it gets the map notify? Because then you're advancing in lockstep.
Map notify copies the nonce from the map. Okay, wait. More clarification. Are you referring to the map notify as an acknowledgement to the map register? Yes. Okay. So because that takes out the discussion about unsolicited map notifies. So since it's an acknowledgement to the map register, the map notify copies the nonce from the map register. And then when the next map register is sent, it could be sent +1 or +n, and the map notify always is what's sent.
Yes. So the only way it could get messed up is if you wrap around the nonce number space. Yeah. Yeah.
I have again two questions. The first one is if I register to two different map servers, I'm an ETR, I use the same nonce. Different.
My implementation does different. I don't know what Cisco's implementation.
If you register to what?
Two different map servers.
You could choose to use the same one. That would be legal, but you're not required to, as I understand
Yeah, I
the
agree.
text.
Yeah, that's
I
true,
agree.
Joe. That's true.
What we say is basically to keep track.
How do we choose the nonce at the beginning? I lost track about this.
Okay, so since the space is 64-bit, and we basically use arithmetic log modulo 2 to the power of 64, we just pick one random, right? And you start with the first one, and then you keep going with the rules that Eric just asked about.
I could share what my implementation does. If an ETR comes up for the first time and doesn't have any persistent storage, it allocates a random number over that 2 to the 64 space. And then it does +1. and it stores it in persistent storage. So if it crashes and comes back up, it can go where it left off.
No more comments or questions? Huh? Okay.
Okay.
Hi, I'm presenting the Lisp EID anonymity on behalf of my co-authors, Dino and Wesson. So this is just to show the document status. It's been around since around 2016 now. And the latest change log is to ensure that we actually show plurality in the creation and usage of the EID anonymity. So we'll explain that a little bit next in the next slide. So what are we trying to solve? We're really trying to make EIDs private and non-trackable. Typically, EIDs are persistent and they're stored in the mapping system where you can look them up. And this whole draft is about trying to make them private and non-trackable if possible, without enforcing more encryption. This is particularly useful in the mobility use cases where the locator part, which is the visible part, is also changing. So we actually have the two changing at the same time, which actually prevents trackability. Next slide. So how do we do that? It's actually a case of where we actually hide in a crowd, or rather in this case, we hide in a pool of addresses. Ephemeral EIDs are just like normal EIDs, they're IP addresses. The only thing is that they come recycled. It's a random number which is recycled within the pool. And the pool is within a specified range. We can use different techniques to generate them. One of them is the crypto hash. The thing is that a source may create one or more of these ephemeral EIDs and start using them. Now, they may actually assign several of these ephemeral EIDs to any one of their interfaces, or they can even have one global folder node. But it might be very interesting, though, to use a different one for each session with the peers so that you really make yourself more invisible in that sense. Ephemeral EIDs should have a limited life, or else they just become a permanent EID as the others. And we can also use them as a one-time only before recycling them, a little bit like having a credit card that you can use only once and then the number changes. Next slide. So how do we do this? What's great is that we do not have really any changes in the base Lisp protocol. It really relies on the exact existing mechanisms already present with the registration and deregistration in the mapping system. What we are really documenting here is also the reservation of the range for the pool of addresses and also some recommendations on how to avoid collision. So the authors would like to request a working group last call. And if you have any questions or comments.
Questions or comments in the room?
The use case is some of the, I don't have an elaborate use case in the slides here, but one of them would be, for example, if I talk to you once and I give you my EID and we are having a live conversation, but that doesn't prevent you later to misuse that EID because now you already know it. But in the case where I'm actually changing my EID all the time, it doesn't guarantee you that the next time you're really going to try to target me can be anybody else. It's the case of this room here. If everybody at one point in their life name can be Dino, then you don't really know whether you're talking to Dino or not. Because anybody could use that as an alias for an avatar just for a certain time. Sorry? Yeah.
Okay. So, well, this document has been around for a while. If it goes to working group last call, of course, will be queued up in the pile of work that the ISG is doing for us. I mean, but anyway, since the authors are asking for the working group last call, let's get a sense of the room. So if you guys think that the document is okay and is ready to be published, please now. Some noise. So if you disagree, so in this case, you think that the document should not be published because there's issue, and in that case, you go to the authors and talk to them. Okay, in that case, you please now. Okay, silence. Okay, we'll take it to the list as the usual process.
All right, thank you.
Okay, I'm going to talk about the ECDSA draft. Next slide. We originally submitted it, Eric and I, back in July 2017, and we went through a couple individual submission updates, and then presented some extensions at last IETF. I think the screen's getting cut off a little bit. Can you scroll up a little bit? There we go, in Montreal. So post-Montreal, we got some comments during the working group in Montreal, and we updated the document at 03 and then requested for working group documents. So this is the first working group document. So basically an overview of the draft. What's the draft's proposing is to authenticate and authorize XTRs using the mapping systems. So we can sign map registers and sign map requests. And only when authenticated, you're allowed to register EID-RLOC mappings. And when you get authenticated for map requests, you get answers back. The draft specifies how to store public keys in the mapping systems and introduces a concept of a crypto EID. A crypto EID is an IPv6 address with a prefix and low order bits, and the low order bits are a hash of a public key. Not only does that allow you to authenticate yourself and look up the public key mappings, but it gives you the right to use that IPv6 address in sending data packets. We introduced something called signature IDs. We called them signature EIDs in the past, but we got commentary last IETF that EIDs were misleading because there's entities that don't have EIDs that might want to use signatures, so we just call them signature IDs. And those signature IDs are the same IPv6, an IPv6 address that has a prefix and a hash of a public key. Next. So what are some of the benefits? Well, we get to use DSA signatures with elliptic curve cryptography. We can verify and invalidate a single XTR, where previously, if you wanted an XTR to not register, you would have to change the shared key, which means all other ETRs that were sharing the same shared key would have to be rekeyed, and that's a big management problem. So now you can invalidate, or by just not allowing the public key to be registered in the mapping system, you could allow XTRs to not register or request mappings. And then we use the signature ID for registering any kind of EID type. That's what we added. So not only you can register an IPv6 crypto EID, but you can also register an IPv4 address, a distinguished name, geocoordinates, all the type of EID types that are in LCAPs. And we're going to show how we can make that secure. So if you register an IPv4 prefix, an EID, and you sign it, the question is that you're saying Dino is registering this prefix, but you don't know if Dino's allowed to have that prefix. Was it actually allocated? And by using multi-signatures, we can now validate that, and I'll explain that in a second. So you can use the public key for encrypting results as well, but the spec does not talk about encryption, just authentication. So now that an XTR has a public-private key pair, that public key could be used to encrypt messages to it. So we have some interesting things we could do in the future with the mapping system encrypting control messages. And we provide identity privacy. Multiple key pairs could be used. So like Padma was explaining with ephemeral EIDs, we could constantly, if you're using crypto EIDs instead of random numbers, you can constantly check or change key pairs. And we find that the cryptocurrency and blockchain algorithms use that. They go through key pairs very quickly, and it's very secure. So any public keys that are in the clear or in the network anywhere are only one-time use keys. So it adds more security to it. Next. Okay, so some of the changes that went into the 03/00. The 03 was the individual submission. The 00 was the first working group. It was one in the same changes. We just changed signature IDs. So every signature that appears in a map request or map register is accompanied with a signature ID. And that allows the map server to look up the signature EID in the mapping system to find the public key to verify the signature. Okay. And then we added multi-signatures to allow a particular ETR to register other types of things. And I'll show you in the next slide an example of that. Oh, one other thing is, since we allowed signing map registers and map requests, we also can sign map notify messages too. So if you generate a key pair in a map server, then a map server could actually sign a map notify. So when you get a notify telling you that there's an RLOC set change, you know it's coming from an authenticated map server. And this is the way the map notify would look. There'd be an RLOC record in there that would have the signature, and then the signature ID would be its crypto ID. So here's an example where this is a public key mapping. It has 4 records in the mapping system. So basically, the crypto EID that has the low order 64 bits of that 11223344 is registered to the mapping system with this EID called #- as an ASCII string for instance ID 1000. So when it's what this is a public key mapping. So when a particular map server gets a map register with this, gets a map register, and it's saying that its signer ID is this 11223344, the map server can look up this record and get that public key that you see there as the first RLOC record and verify the signature. Now, what we added was additional records where other entities could actually merge the RLOC set into this entity. So this guy here, 2001::1111, this is another entity that's saying we are going to allow this XTR to register 111/32 in IPv4 EID. And so what happens is that if that public key is available and verified in the mapping system, that means that that entity is allowing this guy to register it. Now you could see that you could have multiple guys for 111/32, and you can do a 2/3 rule where if 2 out of the 3 signers have signed it, that means they're allowing you to register that. And so so what happens is when the map register is being received by the map server for this EID 111/32, it can verify this. And I just show you 2 more records that could be, well, the 2 there, it requires 2 signatures from : :111 and : :222. But maybe that guy wants to register his geo coordinates, and you can see that just one entity allows it. So if the signature, if the public key is not there or the signature is not part of this thing, then you can't allow the EID. The map server would reject it and only allow it to register the things that it has signatures for. Things that we could work on in the future in this spec is that we put this on the to-do list last IETF, and I didn't spec it, but RLOC probe requests that go from ITR to ETR could actually be signed as well. So an ETR that gets a probe could only respond back to authenticated ITRs. And we also are finding out that, RLOC probes contain a lot of information, rekeying for Lisp crypto. It also can contain telemetry data. And so maybe the ITR wants to authenticate the ETR to make sure it's the right place where it can trust this telemetry data, okay? We can consider encrypting map registers from ETR to map server using public key of the map server. And we can also do the same for map requests from ITR to map resolver. So now that we have this public key, these key pairs, we can do interesting things. Now with asymmetric keying, you're limited on the number of bytes you can encrypt. So Fabio had an idea where maybe you just encrypt a session key and you append that to a map register. And since you can then decrypt it and get the session key is used then to decrypt the entire message. So that's a pretty good idea. That would require protocol changes, obviously, but we'll decide the working group should decide if we want to put these features in. The big advantage is a lot of people are saying that they want all interaction with the mapping system to be private. They don't want to know who's registering what EIDs with what RLOCs, and they don't want to know who's requesting what EIDs. So all that interest N squared talking and who wants to talk to who needs to be private. And then we can consider encrypting map replies as well from the ETR or when the MS is doing proxy replying back to the ITR using public key as well. And the same thing for the pub sub case. Okay, questions?
Question or comments? I have actually two. One is on this slide, I mean, it's all interesting, but this means that maybe we will have to update the upcoming new specs somehow, right? Maybe.
Well, yeah.
Depends.
So I was hoping that we would do this independently of those specs and let those specs go on.
Yeah, absolutely.
Because we have a lot of use case documents that are future things, right?
My point was we continue to work how we are doing with these documents independently. But
Yeah.
then you have to make sure if there is an update to the main spec. In that case, you have to declare. That's my point.
Right. Oh, absolutely.
That's
But the deadline is we're not trying to squeeze it in.
No. Right.
Yeah, good point.
Do you think, Dino, there are going to be such changes? I don't think you're introducing anything new, right, compared to what is.
Well, if we do your idea, we have
to
have to append that to the end of the file. Yeah. Or if you have a separate document that says we just encrypt the EID record and we can keep it under 256 bytes, then we don't have to. We just have to say there's an understanding between the two ends of the implementation that you're going to need a bit to say it's encrypted versus not, right? Something like that. So there's most likely going to have to be packet format changes to support it. So the idea here is to get more. We've been experimenting with this for about a year now, just the regular signing, and we want to get more experience with multi-signatures and stuff. So we're not ready to carry it forward any more than just keeping it a working group document. And maybe next IETF I can show you an implementation of the multi-signatures and how it can work as a high-level use case. And then we could play around with. I'd rather not implement and prototype the encryption part of it until we can spec it out.
Yeah. So there is no dependency on EID anonymity and this one, right?
No, they're complementary, yeah, exactly. They're complementary pretty much.
So one comment, I think that the notion of being able to encrypt everything that is sort of possible to do here is interesting. I don't know if anybody's looked at what's the performance impact of using public key crypto for all of that, right? As opposed to figuring out a way of having some symmetric scheme if you're going to do that.
Yeah, what Fabio's idea is you do asymmetric encryption of just a 256 byte session key or something like that. So it would
but
just
you're still doing it for every message, right?
Yeah.
Independent.
Control plane.
Yeah, but you could also say, well, if I'm talking to this map server all the time, I could actually create some session key for that.
Oh, have a more formalized security association.
Yeah.
Right. Yep. Or maybe if the session key is not negotiated in the map register, use the last one used or something like that. Right.
Yeah, having some feel for, well, how many map registers, map requests, whatever can you actually do, right? What's the actual performance implications?
Sounds good.
ECC is supposed to be more efficient than RSA, but still, right? Is this 2 orders of magnitude slower than running it with symmetric crypto?
So I'm doing some experiments now where I'm just encrypting the map register using Cha-Cha only with the shared key that exists between the security association between the two. And I'm trying to do some performance measurements on that. So I could report that. Yeah, it's not AES though, it's Cha-Cha 20, so much faster, smaller keys.
Okay, no more questions? Thank you, Denise.
Okay, this is a draft IETF Lisp sub. I'm doing the presentation on behalf of Alberto Rodriguez Natal, that is stuck in San Jose. Okay, next. I don't see from here. So the changes introduced. So the first change was already mentioned by Albert when he did this presentation. Basically the site ID and XDR ID definitions and the corresponding IANA consideration have been moved to 6833 bis. And this is because basically now we want to have that definition in 6833 bis. Only for the map register. Yeah, exactly. There are a few security considerations that have been added. So one aspect that came out of the discussion in the mailing list is that there is a rate limit that has been introduced for map notifies when are sent from the map server to the XDR ID. And the concern was that you don't use the PubSub will not be used as a way to basically overload an XDR. And then there is a discussion that we have been having in the mailing list and partially in the last couple of days here. And basically it's how to handle the nonce in map notifies. And we can go to the next slide that is providing the details about this one. Okay, so I start from the first one is that there is a discussion on if we should include or not the updates RFC 6833 bis in here. And I think, the right people are discussing this and they will come up to the right conclusion. And the other discussion that is open is how to deal with the nonce. So this will be reflected in the mailing list and I think in the next version as it was discussed very recently. But the idea is that with PubSub, we are using the map request as a way to subscribe basically an XDR. So since, as described by Albert, we have changed the use of nonce to become basically a sequence number to prevent replay attacks. The question is, should we change that also for the map for the publish subscribe protocol? So in publish subscribe, the reply attack is relevant because if I want to subscribe to a mapping, somebody could reply in that message and subscribe me again or unsubscribe me again. So the conclusion is that when we use the map request with the semantic of a subscribe, we should have an anti-reply protection mechanism that is exactly the same that we use in the map register. And this will basically be handled exactly as we describe in map register when messages are sent from the XDR to the map server. The PubSub protocol has also another message that is another protocol that is basically sent from the map server down to the XDR. And again, the question is that protocol subject to replay attacks? And the answer is yes, because if you receive a publish from the mapping system, somebody could reply that that publish and basically reuse one that you have sent in the past. So exactly for the same reason, we are going to use also the renonce that is basically avoiding reply attack that are mounted
against the map server sending notify as publish messages in the PubSub protocol. So this will be exactly the same mechanism that we're using for map register, and it will be the draft will be updated reflecting this. What that means is that we have a nonce that goes basically from the XDR to the map server and prevents reply attack in that direction, and we have another nonce that goes in the other direction from the map server to the XDR, and these two are unrelated because the two protocols are independent. The subscribe and the publish protocol are independent. Okay. Any question? Okay. Thank you.
That was quick.
Let's do it like this. Hello, I'm Victor Moreno. I'm going to talk to you a little bit about what we call an overlay. We've been discussing whether this is multiple domains or multiple overlays. I think we concurred on calling this basically a concatenation of multiple overlays. So the problem we were trying to solve was basically we have customers creating relatively large networks with Lisp, and as they progress in their journey, we've basically come to understand that they need some level of segregation of the network fate and also of the network functionality. So some of these networks have very high sensitivity, and we basically have pockets of the network that need their own mapping system, their own set of resources, and are able to basically survive failures in other networks. So what we want to do is basically structure the network as a series of sites that are connected by a transit domain or a transit overlay. These are all entire Lisp networks with their own mapping systems, with their own XTRs, and they initiate and terminate their tunnels in the site. So what the document is about is basically the interaction between the multitude of sites and that transit overlay area.
Victor,
yes.
If I can interrupt you right there, because looking at the draft, I was left confused. So the first point I'd make is that the comment you made just now about having a mapping system or a portion of the mapping system that this site can take responsibility for, and therefore, it's only intra-site connectivity works as long as this site is working. That's an important point to call out that is not clearly called out in the draft. Having said that, the converse, a lot of the rest of this seems to actually make robustness and survivability worse. And since the whole design of Lisp was to be extraordinarily scalable, and that the mapping system was extremely flexible, I'm left going, well, this doesn't really improve mapping system scale, because the ability to delegate in any of the mapping system in versions we've used gives you very good scaling already. And this introduces re-end caps and additional specific points of failure along the intersite paths, where if you didn't do this, your intersite communication would be more robust because it wouldn't be going through a small set of tunnel routers. So I'm left, it's not that you can't do it, it clearly works. But except for the mapping system, and I think that could be done in simpler ways, most of this looks like it actually undermines its own argument instead of bringing us further forward. And so I think you need to focus on that more. If there's a benefit, then it needs to be much better explained before getting into the details. I mean, I see how you can make it work. I don't see why.
So this is Dino. So I think we mismessaged the benefit. The idea wasn't we were stating we're trying to make the mapping system scale. Well, those are three independent mapping systems that are managed independently. It's not a subtree of one versus the other.
But why are they managed independently?
Because the sites, so what is a site overlay? It's a set of XTRs and a mapping system where they encapsulate to each other. And it's managed and wholly owned by one organization. Okay.
So wouldn't it be, if you're just worried about the mapping system, wouldn't it be simpler to see if there's a way to basically attach this set of mapping system, which has delegated some things, to a larger mapping system and inject all the information? Because
that's what we do today, but you have to coordinate with another organization.
But you're going to have to coordinate for all the intersite stuff anyway, and you don't have to coordinate. If you can't reach the other organization, you just operate locally. It should be possible to solve this problem purely inside of the mapping system. And we entertain lots of mapping system alternatives. That's one of the nice properties of Lisp, without getting into the complexities of adding tunnel routers to provide interconnection. And I think by mixing the two, see, the claim that it increases robustness, it actually seems to, from where I sit, decrease robustness, because now there are 2 points which, if both of them fail, you have no intersite connectivity, where before you'd have to fail all of your internet connectivity to lose it.
Right. I think that's fair, Joel. One of the things that we did in basically coming to some of these, I'm not going to call them conclusions, but ideas, was basically evaluate if we could do this with DDT as is, right? And one of the things that happens in these networks is we have a high degree of mobility, and we want to re-anchor basically the devices as they move from one place to the other, right? Which was not evident how we would actually do with DDT alone. But you're right, the DDT gives me a distributed structure where I could actually emulate those mapping systems, but I don't have a good way of rehoming a moving device, right? So,
well, but if the only thing that's injected into the overlay is the aggregated information, which is the only way this scales, then if I rehome from one site to another, I actually don't get connectivity unless I change my EID. The whole point is not to have to change my EID when I move. So again, I'm left with, this doesn't seem to match what we've said are our objectives. Now, maybe the point is we have some different objectives, but then the document needs to start by being really clear about that, and the slide decks need to start by being really clear, because these vague statements make me look and go, but most of this is what Lisp does for me.
that's fair, and we'll work on that. But in any case, we came up with it because we really couldn't solve it with the tools we had at hand. Doesn't mean that this is the way to do it. We could look into evolving the tools that are in the toolkit, but I
mean, if we need a small change in the mapping system, that seems a lot cleaner than using tunneling to get something that claims to be robust and scaling. I much prefer the EID anonymity for that.
Right.
Go ahead.
So
you can't have EID anonymity without IPv4, and they still have to solve IPv4.
yeah. So anyway, so hopefully it's clear what it's doing. Point taken. We need to justify why.
Yeah.
So single network really, with a single set of instance ID based segmentation and contiguous mobility domain, where we intend to preserve our IP addresses. So what the draft is attempting to explain is basically how you could actually get this to work. Basically, from a control plane perspective, the XDRs, or every site will have basically its own set of XDRs, its map servers, and there's basically this role of a border XDR that connects the sites to the overlay. And you can think of the topology from a virtual network perspective as a daisy, right? With the core of that daisy being the overlay and all the petals being the site overlays. Now, what takes place is basically the XDRs are going to register the local EIDs into the local mapping system, And that set of registered EIDs is going to be published using PubSub to the borders. The borders in turn will actually take those and register in the stable state. They will register basically the summary of those EIDs, an aggregated route. In the case of mobility, we will see that we actually start registering more specifics so that we can support the EID mobility procedures. And the other thing that is interesting at that border is that we're going to register defaults. So there is a default registration, not necessarily a 0/0, but basically the notion of registering a default that would behave similar to what we do to calculate the covering prefixes for NMRs. But this would actually be used to calculate an actual map reply. The idea is that for most cases, we would actually have any communication that goes beyond the site follow that default. So we're not creating remote state in those sites. So that's all the control plane interaction, and basically what you end up with are the registrations that you see on the right-hand side of the diagram, right? So you've got the local elements, as you can see at the top. You've got 1.1/16 and 1.2/16 with their corresponding RLOCs, and you've got a default for everything else, and that points to your border XTRs. Yes, go ahead.
This is Dino. Based on what Joel said, the 2.1 and 2.2 could have been aggregated since they share the same RLOC set. So we could have actually reduced the number of EIDs in there.
Yes. So once you've created the state, what takes place is pretty standard. We've tried to basically keep each domain doing, for the most part, exactly what we have in place. So what the draft calls out are the exceptions that need to be implemented at the borders to actually create this concatenation of overlays. So if I go through a flow, basically I'm going to issue a map request, and that request being for an EID that is remote is going to come back with a response that is the default. The default points to the borders. So you can see that second step, which is basically I'm going to tunnel my traffic to those borders. When I get to the border, I issue a new lookup. In that new lookup, I have to decide which mapping system I'm going to look at. One of the things that's happening here is that we have had those borders actually subscribe to all the local EIDs. So when I look at the border has a single cache. That single cache is going to have a match for anything that's local, and it's going to have a miss for anything that is across the overlay. So we're going to do that lookup, and we get as a response the XTR or the RLOCs for the remote XTRs. We go ahead and step 4 encapsulate to that remote XTR. And at that remote XTR, since that is subscribed to the local EIDs, we already have cached the final destination XTR. So we basically at that point simply decap, re-encap based on what's already cached in place, and we get the traffic out to the final destination XTR. So the functionality is basically anchored on the role of that border XTR. If I was to summarize, basically, I'm simply connecting site overlays to the overlay. I'm using re-encapsulating tunnel routers for both unicast and multicast. That border is also the point at which I'm going to exchange information between the mapping systems in the site overlays as well as in the overlay. Part of what I do at that border XTR is also constrained which advertisements go into the site overlays. As we said, we're basically registering a default. When I register that default, if I don't absolutely have to register something into that site overlay, I'm going to basically have the border preclude that registration. So for example, if I have the flow that we talked about in the previous slide, if I do a map request and I get a mapping for that, I'm not going to have the border register that into the site overlay. Whereas if it's a mobility case, I'm going to actually go do the registration, and the XDR would have to run some logic that creates a split horizon type behavior so that I don't register stuff that I've learned from the remote sites and then learn it back from my local mapping system. All of that's in the draft. So there are two RLOC spaces. So one of the things that we found beneficial about this approach is that I have the ability to actually keep the RLOC spaces separated, which means that I can now have sites that have their own private underlays, and it's not necessarily routable across to the other sites or the overlay for that, or the overlay underlay for that matter. The other thing that the borders must, so the borders handle basically those two RLOC sets and the two separate disjoint RLOC spaces. In the EAD mobility case, there are basically two away tables that are formed. There are basically each domain or each overlay is going to have its own mobility environment. So these environments require away tables to keep track of anything that may be misrouted to old cached locations. So you're going to have one facing the overlay, one facing the site overlay.
Actually, the split horizon's a little bit tricky because you have site prefixes which are going to show up from the overlay into the local site legitimately if there's been movement,
yes,
but accidentally if there's something else going on. It's going to be,
correct.
I know you called it out in the draft. It's a little bit tricky. I think you can make it work, but
yes,
it is a bit tricky.
There's a couple of checks that we put in the draft, but yeah, for sure, it's one of the trickier things. Right.
Well, yeah, but I'd hate to be trying to build logic that depends on the RLOCs with which one receives the information is fragile.
Yes. We also suggested some checks on the actual away tables, which basically indicate if it's a mobility event or not. But for sure, it's one of the interesting parts of trying to get this to work.
It clearly can be done. I'm not saying that.
Yep.
It's just.
Well, we had this exact same problem with EID mobility. The question is there somebody spoofing you over there on that subnet, or did the guy actually move there?
Right.
And that's why you had to put access lists on there to.
Right. And that's and those procedures at those end systems are consistent with the AD mobility procedures, and we've tried to basically make sure that we don't reinvent things where not necessary. The other thing that we do is we relay events across the domain. So here I have called out that we relay mobility events. There's basically map notifications that go back to the departure sites. We are going to also relay map notifications that go towards the sources of multicast, right? So basically we're relaying a lot of the signaling, and that's one of the principles of how these borders work. So
they in many ways behave like they were one mapping system.
Yes, you could say that. The only difference being if there is a failure of one of them, basically all the other sites remain unaffected, right? That's the, yeah.
I get.
Right. So this is the analogy I was trying not to go into, but think of the overlay as area 0, and you have a bunch of peripheral areas connected to it.
And we found this to be painful in many cases, which is the fundamental.
Yes. Yeah. So each site overlay will follow basically the procedures of EAD mobility. There are some additional things that the border XDRs would do for us. Basically, we're going to install the roaming EADs in the away tables that are facing the arrival sites, right? So I think that's the best way to summarize it. There are detailed workflows in the document, but the best way to summarize it is basically we populate those away tables, and then we take the queue from the map notify message that we receive, and then we initiate registration in the departure domain, and that triggers all the AD mobility procedures. Similar thing with multicast. We strictly adhere to 8378 signal-free multicasting. And we basically have the map notifies go towards the sources or the RPs, those sources or NRPs. If this is inter-site multicast, basically those map notifications will hit the borders, and that triggers basically registration of multicast interest in the next overlay. So it basically gets daisy chained. One interesting thing is that the border XCRs actually provide a natural point of replication for head-end replicated multicast, right? So at each boundary, you're basically providing a point where you are reducing the amount of replicas that you have to put onto the network from the very source. There are some VPN considerations when you do this. You have the ability to scope the instance IDs that you use in the different sites if they are not going to be used for the purposes of cross-site communications. So I could have basically dedicated instance IDs in each overlay site, or I could have global instance IDs, which are actually going to give me services that cut across all the different domains. So I guess the bigger next step is to fine-tune the motivation behind this and justify how it cannot or does not get satisfied by existing mechanisms.
This is Dino. So one other benefit that we didn't talk about is how these overlays and site overlays can help the underlay. Since the inside a site overlay, since you only encapsulate the RLOCs that are in that region, those RLOCs don't have to be redistributed into anywhere else in the underlay. So it does help the underlying routing system not require routes for everywhere. So there's these containment sort of benefits. I don't know if it's compelling, but it's a little subtle.
Right. Yeah, I tried to call that out as the segmentation of the RLOC space into the regions.
Sunny from ZTE. I have a small question. Will beer be used in the inter-site multicast BIR multicast technology? Will it be used in here?
Would we use inter-site multicasting?
Yeah, it will be used, and you will add it in your draft, right?
Yes.
Okay.
Yeah, it's all documented in detail in the draft, but basically it's a concatenation of signal-free messaging for interest expression. So if I was to summarize what you do in signal-free multicasting, you have anywhere where there's attached listeners, there will be basically a registration into the mapping system. That registration triggers a map notify towards the source or the RP, depending on whether it's ASM or SSM. That notification will basically make its way to the border. That triggers basically a registration from that border into the next domain of interest. And that sequential concatenation of events eventually gets to the actual source.
Thank you.
Have you thought about sites that use different encapsulation, or does it make sense to think about it?
That's a good point, and it could be one of the things that drives this, right? Encapsulation translation. Dino was also mentioning natting at those sites. So when the underlay requires natting, you have basically the ability to actually do that kind of thing at that border. Translation of encapsulations might very well be one of the reasons to do this. I think it naturally happens, right? If you have Lisp sites and VXLAN sites, and
if we look at the International Civil Aviation Organization use case, right, that's the case, right? There might be a different transport, or there might be different organizations. So that is probably
right
the use case that is compelling in this case.
That's a very good point, right? So part of what's driving this, and Fred Templin is not here, but he's presented a few times his case for having basically the civil aviation ground network be restructured, and one of the things is that it needs to be modular. So different countries are going to choose different technologies, and they will meet in the center of this. So part of what it's motivated the development of this has been basically achieving that modularity, so that we can have basically different.
Now that's interesting. If the point is that different parts of this may be using different mapping system technologies, then that would be an argument for not wanting to simply concatenate the mapping systems.
Yeah.
That's an interesting different argument.
But also organizational separation sometimes is harder than different technology in the real world.
I think we could make so we could have a common mapping system that had clean enough boundaries that we could make that work. But if they really want different ones because each one is making its own choices about what to use, then it doesn't matter how I structured it. I need to completely separate the mapping systems, and then going back down to the XTRs is about the only way to get a clean separation. But it's not scaling. It's a very different, but relevant.
That's very fair.
Yeah,
That's
yeah.
very fair.
And I
Frankly,
think-
we were more.
That's why my issue here is mostly trying to understand what we're really solving and why.
Yeah, yeah. No, and that's very helpful because I think that it allows us to articulate the
Better
motivation.
views. I mean, frankly, to be honest, we were very preoccupied with making it work. But yeah, very, very fair and useful comment. Okay. So if there aren't any other questions or comments, that was it.
Okay.
Thanks. Bring it back to a standard.
So because Sharon is not here, this was the last presentation of this session. And we have time if anybody wants to go to the mic and have a discussion on any point that we spoke today or any way related to the working group, obviously. Nothing. So I guess we can adjourn. See you again in Prague. You are free to stay.
We have the blue sheets. Thank you, guys. Did anybody need to sign? Thank you.
We have audio crossover instead of because the audio leakage between the walls.
Oh.
The kind of speaker was broken.
The second.
There's one on
But I think the speaker in the other room that's sitting right behind.
Can you reach down? Thank you.